We are going to be discussing on what happens when light rays pass through some gas or something. What do you think would happen to the spectrum? So as you can see, when there's nothing that the light rays are passing through of, it just becomes a normal light spectrum. But what if it was passing through some gas, some XYZ gas? Do you think the spectrum is going to change or not? Well, the spectrum actually does change, but by a little bit. Because as you remember in the last video, any sort of object, except if it's transparent or transparent, it always has to absorb something. So as you can see here, this gas has absorbed some small parts of the spectrum. And now, by knowing that whenever the light rays are passed through this gas, these like 656, 486, 434 and 410 are always absorbed by that gas. We can now identify what gas it is just by using light and light spectrum. So by doing that, we have found out that this is a hydrogen. This is a hydrogen gas. So I've taken the example of a hydrogen gas because this is a hydrogen absorption spectrum. Now you might be wondering why it's called an absorption spectrum. Well, that's simple because as you can see, all these gaps are being absorbed by the light, by the gas, and everything else is still being emitted. So that's why it's called an absorption graph. And as you can see, it's also majority of the light spectrum is still there. So now you know that the what an absorption graph is, but there is another type as well. That is called an emission spectrum graph. So this is nothing but you see these exact four that were removed from the absorption spectrum are there in the emission spectrum. So how do we even find an emission spectrum, or how do we detect it? Well, as you remember in the last video, what is emission? So emission is nothing but when the light rays get absorbed by the object and are re-emitted. They are re-emitted. Now as you can see, the light rays, they have been absorbed. They were absorbed here, right? And now these exact same particles, their light rays, they're getting re-emitted on this side. So as you can see, they would get re-emitted. And since obviously it's being re-emitted, whatever has been absorbed by the gas will only be emitted again. So as you can see, only these four are being emitted in the spectrum of light. So these are the absorption graphs for the following materials: hydrogen, helium, carbon, nitrogen and oxygen. Now, why do you think that these like materials, like why do you think we even need to identify these materials in outer space? Well, it's obviously because if we could identify these materials in outer space, then we would know they would be suitable or not for humans to live. For example, if there was just hydrogen or helium on in a planet or on a planet or in the outer space, then obviously we cannot just live there. But let's say if there was oxygen, then we know that we can breathe and maybe we can start living there. So as you can see, it's pretty important to identify the wavelengths, to identify the materials, and this is a pretty simple way of you finding it. In the next video, we'll talk about how we could find the distance, how we can find the distance by just using light again, how light years really work. Thank you.